All right, today we're doing lesson 6.2.5. The main purpose of this lesson is we're no longer teaching you system equations methods like the substitution or how to manipulate a problem to make it into substitution, or the elimination, or difficult ones where you have to multiply through and then eliminate. Today, and by the way, when I'm looking at that word elimination, I think I spelled it right, but I could be wrong. I did not run spell check, and as I'm looking at it right now, it doesn't look quite right. I'm sure all of you will come in and tell me tomorrow whether I spelled that right or wrong. Anyways, I guess that's why I'm a math teacher. All right, so let's take a look at an equation here. Y equals 2x minus 4 and y equals negative 3x plus 2. In this equation, which method would work best? Now, you'll notice I have the equal values method. If you're questioning, going, well, Mr. Anderson, we haven't learned that. Actually, you did learn that. Way back. I think it was in chapter 2 or 3, or no, not 3, 4, 5. I don't know, chapter 4, chapter 5, somewhere back there. You learned the equal values method. What is that method? Well, I remember that is the one where I said if y equals this and y equals that, we know that y has to equal y, which means this has to equal that. So you simply would take, to set this one up, would go 2x minus 4 equals negative 3x plus 2. And then you'd solve for x. You'd plug it into both equations and solve for y. So in this kind of equation right there, we would choose, come on up here. There we go. We would choose the equal values method. Hopefully that makes sense. All right, so let's do a different problem. Oh, computer's a little slow today. That's all right. Oh, and it won't give me any other information. So now let's give another one. If we have a problem that says something like x equals 2y plus 7, and we've got another one that says 3x minus 4y equals 6. What would be the best method for this? Well, in this case, anytime you have a single variable all by itself, in this case x, in my opinion, it is always best in that position, in that time, to plug in and use substitution. Why is that so easy? Well, because if you do that, you simply take the bottom equation and we rewrite it. 3 times the sum of what we know x to equal, which comes from the equation above, 2y plus 7. And then we finish the rest of the bottom equation, minus 4y equals 6. So now, you know you just distribute, combine your like terms on the left side, and solve for y. That should make sense. So anytime you have a single variable up here, I think substitution is the easiest method. Okay? Hopefully that makes sense to you. What about if you have something like this? 3x minus y plus y equals 14. And you get negative 2x plus 7y equals negative 24. So now the question becomes, which method is the best one here? Honestly, this is your choice, okay? Some people would prefer to do the substitution method on this one, okay? Well, if you do the substitution method, you've got to take that top equation, and let me change the colors of this one real quick, okay? You'd have to take that top equation and rewrite it as y equals negative 3x plus 14. You might have noticed I just subtracted 3x from both sides. Then after you've done that, then you could rewrite the top equation. Let me go back to my normal color here. And you'd rewrite the bottom equation using the information that we just came up with, which is negative 2x plus 7 times the sum of what y is, which we now figured out to be the negative 3x plus 14 equals negative 24. So you simply rework the first one, and then you plug this information in for your y value right here, because that's what y equals, and then you can solve for it from there. Distribute, combine your like terms on the left side, and solve for x. However, you may not like that method. You might prefer to use your elimination method on this one. If you do like to eliminate, if you would rather do the elimination method, then you've got to do your multiply first, which means in this case, what I would probably do, because it seems the easiest, is multiply the top equation by negative 7. So you've got negative 21x minus 7y equals 14 all over negative 2x, I'll line up my symbols here, plus 7y equals negative 24. But you got to be careful when you do this, because it's easy to make mistakes, as I just made right here. If you notice on the very top one, I multiplied the 3x by negative 7, I multiplied the y by negative 7, but I forgot to multiply the 14 by negative 7. When I do that, I should have actually had a negative 98. From there, you should be able to see your y's will cancel. We have a negative 7y and a positive 7y, so those will cancel. When you combine these two right here, you're going to have negative 23x equals negative 122. And you would solve from there. Obviously, that would not turn out very nicely, because I'm just making these up on the fly. So this equation right here, you could choose the substitution method if you rework the top equation and move the 3x over here, and that becomes a negative 3x. Or you can work it using elimination. And in this case, you'd want to multiply the top by your negative 7. So that's one where you could choose either one. So, whoa. That's better. So now what about an equation like this? On an equation like this is one I would call, this is one I refer to as a simple elimination one. You should be able to kind of recognize early on, I've got a negative 4y on the top, a positive 4y on the bottom. That makes no sense whatsoever to rework numbers around to do substitution. In fact, the only thing that truly does make sense is to eliminate your y's right here. So you've got, when you add these two together, you've got 9x, and when you add these two together, you get 29. 9x equals 29, and solve from there. Again, I'm making these up, so that wouldn't work out very nicely. But it should make sense when you have two variables that can easily cancel. Use your elimination method. Okay, well, what if they don't eliminate just nicely? And we have something like this. 7x plus 3y equals, 7x plus 8y equals 16. 16 is on the top. Let's do a different number, negative 32. Okay, now on this one, if you investigate your numbers, 2x and 7x don't work particularly nice together, but negative 4y and positive 8y, they're not too bad. I mean, what do we need to do to the top equation to get our y's to cancel? We need to multiply by 2. That would be pretty simple. So if you multiply the top equation by 2, and I'm just going to change colors for this one, you would simply have 4x minus 8y equals 32. That way these two would cancel, and you would have this over here. 7x plus 4x is 11x equals, oh, that didn't quite work out the way I'd like it to, equals 0, so x would be 0, and you'd solve for y. But I think you get the point. That would be an easy one where we multiply the top, to equal this, so then you get an easy elimination method. So hopefully those make sense what to do. So which brings us to my last example. What if it's not so clear like that? So again, let's say this is 7x, and this time it's plus 3y equals 27. God, I know, why am I making this hard on myself? Equals 8. Okay? So we've got 7x plus 3y equals 8 on the bottom. We've got 2x minus 4y equals 16 on the top. This one doesn't work out quite so nice. But I got to tell you, in order to use substitution, which I don't like, there we go. In order to use substitution, I'd have to do a lot of configuring, and I'm probably talking about getting possibly some fractions in there. So I don't know that I want to do that. So I would still recommend doing the elimination method. So what I would do is I would find two of these numbers, like negative 4y and positive 3y, figure out a kind of a common denominator type thing with them. I mean, it's not really a common denominator, but what do the two numbers, what could they both be factors of what nice easy number? Well, 4 times 3 is 12, so 12 would be a nice one. In order to get to 12, I would need to multiply the top equation by positive 3. So when I do that, I would end up with 6x minus 12y equals 3 times 48 is 4, 3 times 16 is 48. And the bottom, I need to multiply that by positive 4, so that would be 28x plus 12y, should keep the y next to there, equals, let's see, 4 times 8, 32. Now you'll notice that your y's could cancel nicely, the negative 12y and the positive 12y. 6x plus 28x is 34x, and over here you're going to end up with 80, and then you solve for x. Plug in, solve for y. So this would be one where it would be nice and easy to use the elimination method. The last one to go through. What if this said minus 3y equals 5? Again, this would be a similar one to the one above. You really don't want to use substitution because, again, you're probably getting into fractions. I would use the elimination method, knowing that you got to multiply the top maybe by a negative number and the bottom by a positive number, so either your y's could line up and cancel or your x's could line up and cancel. Hopefully that makes sense, but that's kind of what the lesson is about today, is choosing a method. And the reason we taught you all these different methods is because as you get good at this, if you choose the right method, you become the most efficient at this. Equal values doesn't work in many cases. Substitution can work, but boy, if you're starting to put in fractions at times, that becomes a really complicated method. Elimination method works for every single situation, but sometimes substitution or equal values would be far easier than elimination. So it's really picking which one makes you the most efficient. Hopefully that makes sense. You have a great day.